Okay, so today's lesson on perpendicular bisector is talking about if you have two lines like this, and remember perpendicular we talked about the other day means that then right when they meet they would make a 90-degree angle. But if we're adding on the fact that it's bisecting, it means that if we're talking about this segment, not only is there a 90-degree angle on both sides, but it also means that it hits at its midpoint. So that's the midpoint, and it makes those two congruent segments. So it actually ends up giving you two congruent angles because they're both 90, and it also gives you two congruent segments. So perpendicular gives you two angles, and bisector gives you two segments. So just more that we can add to our proof. All right, so find these notes. It's in that yellow packet, and then fill this in. So the perpendicular bisector, again, is a line that intersects a segment at its midpoint at a right angle. So that means right when it intersects here, not only is that creating this 90-degree angle on both sides, but it also makes this segment congruent to that segment. Okay? Equidistant is the same distance from a reference point. So that means if a reference point is here, like let's say this is where the sun is at, or this is where the top of the building at, equidistant means that if I look 15 meters this way and this way, notice that they both lie on this line. And if I drop this down, it actually makes this the perpendicular bisector. Makes those congruent. That's actually a property we're going to talk about. Okay? Alright, so we have to actually prove the perpendicular bisector theorem. So the perpendicular bisector theorem says that let's actually just go to the given. It says that you're given that AC, so this segment right here, is the perpendicular bisector of BD. And then we know that E lies on that line. So what we're going to do is we're going to prove that this segment BE is congruent to this segment ED. But think about everything we've been doing with proofs. The only way that we can prove that this segment is congruent to this segment is to first prove that this triangle is congruent to this triangle. Because they're corresponding parts, then I can use CP/CTC. Okay? So one of the things we're going to do is if it's a perpendicular bisector, we can say that these are two congruent 90-degree angles. We can say if it's bisected, this segment is congruent to this segment, and then reflexive property, we can say that these two segments are congruent, which then allows me to say side, angle, side, the triangles are congruent, which then means I can say these are congruent by CP/CTC. So it's a long process, but we'll go through it. Okay, so C is the midpoint. If we look at C, C lies on the segment BD. So C is the midpoint of BD. And then we can kind of fill in here. This segment BC is congruent to CD, and the reason is if bisected, then two congruent segments. Sorry, if a segment is bisected, then two congruent segments. That comes from the fact that it was a perpendicular bisector. And then notice here that it's saying right angles. So find in here your right angles. Remember, you cannot call this angle C, but we can call it angle BCE. So angle BCE, and then this angle DCE. So those are right angles because of the fact that they're perpendicular. And then because they're both right angles, we can then call them congruent. So we can say angle BCE is congruent to angle DCE. EC is congruent to EC. You should see these are the same two segments. If you look at your triangle up there, you should be able to see that that's the reflexive property that allows me to say that. Make sure you're putting property on here. Okay, and now if you go back and take a good look, there's one congruent statement, two congruent statements, three congruent statements. Every time I make three congruent statements, my next step will always be that the triangles are congruent. And my reason is side, angle, side. One of my sides I said in step 3, one of the angles was in step 4, and then step 6 from the other side. And then anytime you prove triangle is congruent, your next step will always be CPCTC, because that's the only reason we prove triangles congruent. Okay? And then that's it. So flip to the next page. Okay, so here's the nice thing about perpendicular bisector theorem. It says that if a point on the perpendicular bisector of a segment, then it is equidistant from the endpoints of the segment. That means that if WN is the perpendicular bisector of IO, right where they intersect is two 90-degree angles. Bisector means that this segment's congruent to this segment, but it also means that anything that lies on this line is going to be the same distance to O as it is to I. Meaning, if I'm looking at W, W to I is the same distance as W to O. And I can draw a line anywhere. I could say I'm going to put a point right here, and I'm going to draw it to O, and I'm going to go then to I. And because it lies on the perpendicular bisector, I know that this segment and this segment are the same distance. So it allows us to set up some algebra problems. For instance, so you're given this diagram. They're given that BD right here is the perpendicular bisector of AC. So it usually helps to say, well, if it's the perpendicular bisector, I know those two angles are 90. I know this segment's congruent to this segment. And since B lies on the bisector, I know B to A is the same distance as B to C. You know, all of those things are true just because of the fact that it's a perpendicular bisector. Okay? So then, if I go through and I label what they told me, so angle ADB, so this angle right here is 9x minus 18, so this angle, and I know that 7x plus 6 is CDB, so this angle. I have two ways of setting this up. I can either say that I could say this angle is 90, I could say this angle is 90, or I could say, well, if they're both 90, then they're equal to each other. That's what I'm going to do. So I set them equal to each other because they're both 90 and congruent. If I subtract 7x, I get 2x. And if I add 18, I get 24, which means x is 12. Okay. All right, so in the next one, now we know that the segment QS is the perpendicular bisector of PR. So because this segment is the perpendicular bisector of this segment, we know that those two angles are 90. We know that this segment's congruent to this segment because it was bisected. And because S lies on this line, we know the distance from S to P is the same as the distance from S to R. Okay? So label what we have. We know that segment PS is 3 times 2x minus 5. And we know that segment SR is 3 times x plus 4. And I know because I've already labeled it that those segments are congruent, which then means I can set those segments equal to each other. Okay, and then I just need to distribute. Okay, subtract your 3x, you get 3x. Add your, oops, sorry, that's the wrong number, 15. Add 15 to both sides. You get 27, which means x is 9. Okay, and then it didn't ask us for x, but we needed x. What are the values of PS and SR? Well, PS and SR, so segment PS is equal to segment SR because they're congruent. And then they're both equal to, if I take 9 and I substitute it into either of them, I'm just going to do this one. So 3 times 9 plus 4, so this is 13 times 3 is 39 units long. There's my answer. Okay? Alright, why don't you try to do number 3 and number 4, and then you can unpause this and check to see if your answer's right. Okay, so I've labeled my triangle, and I've written down the expressions that I was given, and because I know that this is a perpendicular bisector, I know the distance from M to N is the same as the distance from M to O, which means I can take those expressions and I can set them equal to each other. Okay. Subtract 6 from both sides, you get 11x. Add 8, you get 33, which means x is 3. Okay, and then it's asking us for the values of, what are the values of, actually, these are the wrong letters, sorry. They're just asking us for the segments MO and NM. So if I substitute 3 back in, I do 6 times 3 plus 25. Okay, and I get 43. So that means that segment NM equals segment MO, and they both equal 43 units long. Okay? Alright, so hopefully you tried number 4. If not, you can pause it. But if we notice, if this segment is congruent to this segment, and this right here is perpendicular, without them telling me, I now know that this is the perpendicular bisector of IO, and if that's true, then that means that this segment is congruent to this segment, and because N also lies on that line, the distance from N to O is the same as the distance from N to I. So they didn't tell me it was a perpendicular bisector, but I knew because this was congruent to this, and those are 90-degree angles. So that means I can set 6x minus 8 equal to 4x minus 2. Subtract 4x, you get 2x equals, add 8, 6. So x is 3. Okay, and if I wanted to, I could do 4 times 3 minus 2, which equals 10. So that would mean Wi is equal to Wo, which equals 10 units. Okay? Alright, so next page. Why don't you go through and try to do these 4 problems, and then you can unpause it and then check and see if your work is right. Alright, so I've set up the equations for you because I'm hoping you at least got that far. So, because this is a perpendicular bisector, here's perpendicular, here's bisector. I know that these segments are congruent because they lie on the perpendicular bisector. So here's my equation, set them equal, subtract 15x, you get negative 11x, subtract 2, you get negative 44, which means x is 4. Hopefully I got that right. Alright, in the next one, you're going to have to set up a system because of the fact that there's an x and a y in the equation. So use vertical angles, and you can say that 4x plus 5y has to be 55 degrees because they're vertical, and then 11x plus 10y has to be 125 because they're vertical as well. Okay? It looks like it's easiest to get rid of my y, so I'm going to multiply this by negative 2, which changes that equation to negative 8x minus 10y is equal to negative 110. I can now add both of these. This gives me positive 3x. My y's are gone. And this gives me negative, oops, sorry, not negative, positive 15, which means x is 5. Okay? And if x is 5, I'm going to go back, substitute it into one of the equations. So I'll do the first one since they're smaller numbers. So 4 times 5 plus 5y equals 55. So this means 5y equals, this is 20. So if I subtract 20, I get 35, which means y is 7. Okay? Alright, in number 7, you're given these angles. You don't know that they're congruent. You don't know that they're perpendicular. You don't know that they're supplementary. But the only thing you do know, or what they told you, is that if I take this angle and I add them up, so sum, they're going to give me 120. So I'm going to distribute. This would give me 24x plus 16. So if I take this angle plus 8x plus 8, the sum of these two angles is 120. Okay, so combine like terms, 24 and 8 makes 32x, 16 and 8 makes 24, that's 120, so that means 32x equals, if I subtract 24 from both sides, I get 96, so x equals 3. Okay, so find x in the measure of each angle. So if x is 3, I'm going to substitute back in, and I'm going to do 8 times 3 plus 1. So that's 4 times 8 is 32. So that means the measure of angle EDF equals 32 degrees. And I know if this is 32 and that's 120, 120 minus 32 equals 88. So that means the measure of angle CDE equals 88 degrees. So there's the measure of one angle, and there's the measure of the other angle. Okay? Alright, last one. Number 8. So this is kind of like, this is pretty much the exact same thing that we did yesterday in the warm-up. So if I know that this is angle 1 right here, notice that this angle, right? Notice that if I extend this line, and I extend this line, you should be able to see that the distance from here to here is the same as the distance from here to here. So those are vertical angles, which means that angle 6x minus 2 is the same as if I add these two angles. So that means if I take 2 times 2x minus 7 plus 3x minus 12, the sum of these two angles is this angle. Okay, so distribute on the other side. I get 4x minus 14. Combine like terms. Negative 26. If I subtract 7x over here, I get negative x. If I add 2, I get negative 24, which means x is positive 24. Both those turn into positive, so there's x. And I also need to find the measure of angle 1. So where's angle 1? So angle 1's right here, so that would be 6 times 24 minus 2, which equals 142 degrees. So the measure of angle 5, make sure we label this, is equal to 142 degrees. And we're done. Okay, so your homework is day 3 worksheet. It looks like this, and it is in your packet. You're just going to be going through some simple algebra problems with perpendicular. You're going to go through the proof. This is the same thing as the proof that we did in the notes, so you can just copy it back down, but try to make sure it makes sense. Let's see, there was something here we're going to change. You can change this one because you should be writing that in an if-then format. So if midpoint. And then the next page, you're just going through algebra problems. These are review, and then that's review. And then that's it. Okay? So make sure these are done, and then on Friday we're going to do test review, so you'll get the packet. And then test on Tuesday.